Assalamualaikum warahmatullahi wabarakatuh. So today we are going to continue with the topic number 6, which is data description. So for this chapter or topic, we are going to have a total of 4 lectures. So the first one, we are going to cover the 6.1 subtopic, which is the introduction, and 6.2 subtopic, which is the frequency distribution. Okay, so the learning outcome for this lesson, at the end of the lesson, students should be able to define the basic statistical terms, which is population, sample, variables, and type of data. And then for the second one, to classify ungroup and group data. And then 6.2a, so identify important terms related to frequency distribution table. Okay, so we are going to have the term of open and closed class, and then class limits, class boundaries, class width, and class midpoint. And lastly, to complete an extended frequency distribution table. Okay, introduction. So statistics, what is this statistics means? Okay, it used in all fields of human activities, including sports, research, education, business, scientific studies, banking, experiment, and so on. Okay, the nearest example we can get you is the COVID statistic. Okay, so we are using this basic knowledge in statistics to do the charts and then the summaries for all the data used to analyze the result of surveys. Okay, let's say we are surveying on your needs in college matrikulasi Kedah. Okay, and then used as tool in scientific research to make effective decision based on experiment. Okay, so we are doing experiment and then we will do conclusion which most effective results. So we can apply in real life situation lah. And then statistics is the science of conducting studies that include collecting, organizing, summarizing, analyzing, presenting, and drawing conclusion from the data. This is the most things we use lah to collect, organize, summarize, analyze, and so on. Okay, so population and sample. So these are the terms that we need to understand. So a population is a collection of data whose properties are analyzed. So we have a collection of data. Okay, so all the data, we call it as a population. It contains all objects of interest. For example, if we are interested in studying the average age of citizens of the Malaysia, the population consists of all citizens of the Malaysia. Okay, but for sample is a part of the population of interest, a sub-collection selected from a population. So this is a subset of population lah. Okay, so for example, we may randomly choose 1,000 citizens of Malaysia and ask each citizen what his or her age is. So the sample consists of those 1,000 citizens. So for population, we are considering all the subject in that interest. Okay, but for sample, we just take apart from the population. So example 1, a study was made regarding the methods of study used by 100 of 2,500 KMK students. So what are the population? What are the sample? Okay, so because the population consists of all the subject of interest, so what are all subject of interest for this situation? It's talking about KMK students. So all KMK students here is 2,500. Okay, all the 2,500 students. But the sample, because we are doing the study of the 100 KMK student only. We are not taking the interview or anything from all the KMK students, but only by the 100 students. So that is the sample. Example 2. Identify the population and sample of the following. So 5 students from account class were interviewed for A. So what are the population? The population will be the all students in that account class. Okay. Okay. All the students from account class, and then the sample we just took 5 that being interviewed. So 5 students. And then how about B? 20 cars of 500 cars were tested for performance. So total car here we have is 500 cars. But for the sample, we just took 20 cars to test. Okay, so the sample will be 20 cars only. Okay, a variable is a characteristic of interest measured for each unit in the population or in the sample. What are we interest of? Okay, so this variable will represent that interest. Okay, so for example, gender, height, age, and then eye color, and then siblings, number of siblings. A variable that can be measured numerically is called quantitative variable. So we can measure that value, the variable that we can measure. For example, salaries of employees, height of students, number of accidents. Okay, and then a variable that cannot assume a numerical value but can be classified into two or more non-numeric categories is called qualitative variable. So the word is quality. So for example, types of jobs. So maybe industrial job or maybe professional jobs. And then academic qualification, it can be diploma, degree, master, and so on. And then colors of cars. So we have several colors of car, which is black, silver, gray, white, and so on. Okay, so data. Data is a collection of observations, measurements, or information obtained from study that is carried out. So all the outcome from the observation and so on we call as data. It's called a data. So there are two types of data. The first one is quantitative data, consists of number representing counts or measurements. Example, the weight of supermodels. And for quantitative data can be separated into different categories that are distinguished by some non-numeric. So the gender, so we can separate into male or female of professional athlete. Okay, so example 3. Determine whether the following are quantitative or qualitative data. So the age of babies in competition. So age we can count, we can measure. It can be 1 month, 2 months, 12 months, 6 months, 1 year. So it will be quantitative. And then the colors of houses in a certain state. So we have brown, we have yellow, we have blue colors. So we cannot count. It's not a measurement. So we can define as qualitative data. And then for C, the weight of parcel in the post office. It can be 200 gram, 500 gram, 1 kilogram, 2 kilograms. So it can be measured. So it will be quantitative data. And lastly, the qualification required for a certain job. So this certain job asks for the degree, or this certain job asks for SPM level only. So it will be qualitative. We cannot measure SPM, diploma, and everything. So it's qualitative data. Okay, so quantitative data can be further described by distinguish between discrete and continuous type. So what it means by discrete? So discrete data can be described by a discrete variable, which is a variable that can only assume particular numerical values. So or certain numerical values only over a certain interval. They are usually obtained by counting. So we can only count. Okay. Example, the number of brand X car that was sold in a month in Malaysia. So it can be 100, 1000 or 200 and so on. And then another example is number of children in each family in town-wide. So we can count as 1, 2, 3, 0 and so on. But what is the difference between continuous and discrete? It can be measured, but what is the difference is discrete and continuous? Okay, for discrete data usually can be found using the counting method. Okay, this is the keyword here, counting method. But there are also cases that do not involve counting, such as 14, 14 and a half, 15 and 15 and a half of shirt size or shoe size. Okay, so what is continuous data? It can be described by a continuous variable that is a variable that can assume any numerical values over a certain interval. So we can take any value, any numerical values over a certain interval. So all the points, if we have a significant figures or decimal points, we can take it. We can consider it. For example, the monthly rainfall in cm for a particular year. For example, we may have 5.3, 5.32, 5.35, 4.8, 6.1 and so on. So we can take any value in between in the in the interval. And then another example is mass in kilogram for a newborn baby. So newborn baby usually will take about one uh, 1.3 kilogram, 1.45 kilogram, or 2.325 kilogram. Okay, so it can be varies number of numerical values, so over a certain interval. Okay, so there are two types also of data, which is the ungrouped and group data. For this one, we can it's for a certain types of data we need to use ungroup, but a certain type of data we can use group data. Okay, so ungrouped data is data in the raw data. So we have all the observations, so that will be the ungrouped data lah. The data has not been organized into groups. It is just a list of numbers. Group data is data that has been organized into classes. Okay, so we can separate this number interval is a one group. So the next interval will be the another group. So we can put all the values in between the interval in that certain group. Okay, group data has been classified and some data analysis has been done, which means this data is no longer raw. These are the number of room in each of 20 houses in a particular town. Okay, so this is raw data. Why? Because we just have the data observation and this is not being organized yet. Okay, so when the data are arranged and grouped, it is called group data. We also can group this into a certain interval. For example, we can consider number of room from 2 to 3, and then number of room between 4 to 5, 6 to 7, 8 to 9. So we just count what are the number of room between 2 to 3. So if we use the tally, we can count here how many number of room for the number of house with 2 to 3 rooms. So we have 3 here, we have also 2, 3, and then 2 here. So how many? 1, 2, 3, 4. So 4. That's why the frequency is equal to 4. And then for the number of room from 4 to 5, so we have 4, 5, 5, 5, 4, 4, 4, 4. So how many? 1, 2, 3, 4, 5, 6, 7, 8. So 8 frequency. And then how about 6, 7? So for 6, 7, we have 1, 2, 3, 4. So we also have 4. How about 8 to 9? We have 8, 8, 8 here, 8, 8, 8. We don't have 9. So how many 8? 1, 2, 3, 4. So 4 frequency also. So this is the group data. We take the raw data into a group data. Okay, frequency distribution. Frequency is how often something occurs. A frequency distribution is a table in which the values of variable are grouped into classes and the frequency of observed value that fall into each class is recorded. Thus, a frequency distribution contains a list of data values and its frequency. Okay, because the name is frequency distribution, so it should contain frequency. So frequency is how often something occurs. Okay, before we construct a frequency distribution table, we will first to know some standard terms used in discussing frequency distribution tables. First of all, open and closed class. So open and closed class are determined by whether the endpoints are included or not. If the endpoints are included, it is a closed class. Okay, so endpoint included, so closed. If the endpoints are not included, so it's an open class. Class limits. So class limit are the smallest and the largest observation, data, event, etc. in each class. So we will have a lower class limit and upper class limit. Okay. So the lower and upper limits of a class are the smallest and the biggest value of the class interval. Okay, so for example, this is our frequency distribution table. So this is our group data lah. So this class is contain how many interval? 1, 2, 3, 4, 5, 6, 7. So each class will have lower and upper limit. So we have lower limit for the first class, which is 200, and upper limit of 299 for the upper limit. Okay. So the lower class limit is 200, the upper class limit is 299, and so on. Okay. So class boundary. Okay. What is the difference between class limit and class boundary? So class boundary, or sometimes referred to as a true class limit, okay, are the midpoint between upper class limit of a class and the lower class limit of the next class in the sequence. Therefore, each class has an upper and lower class boundary. For example, so these are the example of frequency distribution table. So the two types of class interval are shown below and how to find the class boundary. So for the first example A, we have age, years, and then this is the class interval. So notice that we have the upper class limit here is 29. But the next lower class limit is also 29. So if we continue, we add up these two values and divide by 2, we still get 29. So for this case, we have the class limit the same as the class boundary. Okay? So for upper class boundary, it should be upper class of 33 plus the lower class limit of the next class, which is also 33. So divide by 2, it will be 33 also. Okay? So for this type of class interval, you can see the value of lower and upper boundaries are the same as the lower and upper class limit. So you can just use the value from the lower and upper class limit as the lower and upper class boundary. Okay, because it's the same, so we can just use the limits. The next example. Okay, so notice that we have interval of 25 to 29, 30 to 34, 35 to 39. So there is no coincide between the interval. So for the class of 30 to 34, okay, so we have the lower class boundary of 30, right? And then the previous class upper class limit, the lower class limit is 30, and then the previous upper class limit is 29. So we have to add up between these two values and find the midpoint. So 29 plus 30 divided by 2 is 29.5. So this is the lower class boundary of class 30 to 34. How about the upper class boundary? So the upper class boundary, so the upper class limit of the class will be 34, and the lower class limit of the next class is 35. So we have to add up 34 and 35 and then divide by 2, which is equal to 34.5. So now we have to find out the class boundary for each class. Why? Because the limit is not the same as the boundary. Okay, so for this type of class interval, you can add half of the amount to each upper class limit to find the upper class boundary, and subtract of that amount from each lower class limit to find the lower class boundary. Here we need to add up by 0.5 or subtract by 0.5. Okay, class width. The class width or class size is the difference between the upper and lower boundary. Please take note, it's upper and lower boundaries. Okay, it's not limit but boundaries. Make sure you are taking the boundaries value. Okay, so this is the formula lah. And then the class mark or the class midpoint. So we have two names for this part. We have either class mark or class midpoint. So if it's a midpoint, you just have to add up the lower and upper limit and then divide by 2, because we need to find the middle point, right? So just add up the lower limit and then with the upper limit and then divide by 2. So let's see some example. Complete the following distribution table which shows the age of person who buy a ticket at Sunway Lagoon in 1 hour. So determine also the class width of the data. So we need to complete this table. So we have the classes of ages, which is 11 to 20, 21 to 30, 31 to 40, 41 to 50, 51 to 60. Then we have the frequency. So the lower limit, which is directly the lower limit, and the upper limit, which is directly take from the class, which is 11, 20, and then 11. Here we have 11, 21, 31, 41, 51 for the lower limit. And then for the upper limit, it's 20, 30, 40, 50, and 60. Okay, and then for the lower boundary, we need to subtract by 0.5 lah, because if 20 add up by 21, it will be divided by 2 will be 20.5. So we add up by 0.5. So for the lower boundary, we need to subtract by 0.5. So the lower boundary here will be 10.5, 20.5, 30.5, 40.5, 50.5. And then for upper boundary, we add up by 0.5 will be 20.5, 30.5, 40.5, 50.5, and 60.5. And then the midpoint, just add up between the lower and upper class limit and then divide by 2. So 11 plus 20 will be 31, divided by 2 is 15.5. And so on, we get 25.5, 35.5, 45.5, and 55.5. So the class weight, just subtract between the limit or boundary. For class weight, we need to take the boundary value. So the upper boundary we have is 20.5 minus the lower boundary, which is 10.5, which is equal to 10. So the class weight or the class size is equal to 10. So example 5. The following table shows the masses to the nearest of 0.1 kilogram of 40 newborn babies. So this is the weight of the babies, newborn babies. So the total frequency here should be 40 newborn babies lah. So construct a frequency distribution table starting with the first class interval 1.5 to 1.9. So the frequency table includes the lower limit, upper limit, lower boundary. So we need to put the lower limit, upper limit, lower boundary, upper boundary, and the midpoint. Determine also the class width of the data. So now we have the first interval, which is 1.5 to 1.9, and then we need to construct the next class interval. Okay, so if we start with 1.5 to 1.9, the next one should be continue to 2.0 to 2.4. After that, why? Because we can skip one interval to put 2.5 to 2.9. We just change the value in front. So what is in between? So we have after 1.9 is 2.0 and before 2.5 is 2.4. So that's why we have the interval 2.0 to 2.4. Okay, we just can continue the next interval lah. Okay, next, now we just have to calculate the frequency of each of the classes. So from 1 to 5 to 1.9, how many newborn babies? So after we calculate, it will be 1, 3, 9, 16, 10, and 1. Okay, so please count it correctly. So you can use tally lah. Okay, and then what is the lower limit? For the lower limit, we just take the lower value of the interval. Okay, so here we have 1.5, 2.0, 2.5, 3.0, 3.5, and 4. And also the upper limit will be the upper value of the class interval here. So we have 1.9, 2.4, 2.9, 3.4, 3.9, and 4.4. How about the lower boundary? So first, we need to find for the upper boundary of the first class. So we just add up between the upper limit of the first class with the second class lower limit. So 1.9 plus 2.0 will be divided by 2 is 1.95 and so on. So we can calculate also for the lower boundary. So if we notice that 1.95 is just adding up by 0.5. Sorry, 0.05. So that's why we need to subtract by 0.05 for the lower boundary. Okay, so that's why we have 1.45, 1.95, 2.45, 2.95, 3.45, and 3.95 for the lower boundary. And 1.95, 2.45, 2.95, 3.45, 3.95, and 4.45 for the upper boundary. Now to find the midpoint, we just have to find the midpoint, the average between the lower limit and the upper limit. So 1.5 plus 1.9 is 3.4. So 3.4 divided by 2 is 1.7. So and so on, continue will be 2.2, 2.7, 3.2, 3.7, and 4.2. And now find out what is the class width. Just subtract between the upper boundary with the lower boundary, which is 1.95 minus 1.45 equal to 0.5. It's not 5, huh? It's 0.5. Okay. So extended frequency distribution. Okay, so we have this word extended. So what is the difference between the frequency distribution and the extended frequency distribution? So frequency distribution are helpful to summarize large sets of data into small, quickly readable tables. More information can be obtained by extending a frequency distribution to include relative frequencies and cumulative frequencies. Okay, so these two types of extended frequency distribution. So one further extension of the frequency is to the frequency distribution is to look at the percentage of the values that show up in each categories. So if it's a percentage, so we can compare between the class interval which one is the give which is which the which one is the highest, sorry, or the smallest. Okay, so this is called a relative frequency distribution or percent frequency distribution. So we can use a percentage or the fraction. Okay, so the relative frequency is the number of observation of a given type divided by the total number of observations. So we have the frequency, we just have to divide with the total number of observation, total frequency lah. So for example here, for the first one, we have of interval 11 to 20 with the frequency of 3. So what is the relative frequency? So what is the total frequency first of all? So we just have to find out what is the total frequency here. So 3 plus 4 is 12, plus is 7. 7 plus 5 is 12. 12 plus 12 is 24. So we should divide every frequency with 24 to get the relative frequency. So the first one will be the 3 over 24. The second one is 4 over 24. The third one is 5 24, 6 24, 6 24. Okay, here you can simplify lah. This one will be 1 over 8. This one will be 1 over 6. This one cannot be simplified. And then 6 over 24 is 1 over 4. Okay, 1 over 4. How about percent? So what we need to do is just multiply with 100%. So we get 12.5%, 16.67%, 20.8783%, 25%, 25%. If we total up everything here, it should get 100%. Okay? Okay, so number 2. A cumulative frequency distribution is a way to list how many values fit into the first class, the first two classes, the first three classes, etc. or the last cluster and the last two classes, etc. The cumulative frequency distribution can be obtained from the frequency distribution. The cumulative frequency of a class is found by adding the frequencies of all the classes below and until this particular boundary. Before that particular boundary. Okay, here we know this is the interval, class interval, and the frequency. So what is the upper boundary? So we can take 20.5, 30.5, 40.5, 50.5. How about the cumulative less than 3, less than the cumulative frequency? We just take this frequency and add up with the previous frequency. So for the first class, it should be the same as the frequency, which is equal to 3. But for the second class, it's 4, but we need to add up with the previous. So you can direct add up with the cumulative frequency before that class. So 3 plus 4 is 7. And then for the next class, 31 to 40, this 5 we can add up with 7, which is equal to 12, and so on. So 6 add up with 12, and then 6 add up with 18, so we get the next one. Okay, so this is how we find out the cumulative. So the total should be 24 lah. The last frequency, this cumulative frequency should be 24, which is the total frequency. So let's see the example 6. The following data give the number of pieces of junk mail received by 31 families during the past month. So we have classes of 5 to 8 junk mail. So we have a 3. So 3 family has the 5 to 8 junk mail. And so on up still to 25 to 28 jamel. We have two families with this number of jamel. So based on the above frequency distribution table, construct relative frequency distribution table and cumulative frequency table. So what we need for the cumulative relative frequency distribution table? So we just have to add up the relative frequency and the percent lah. So for the relative, we just have to divide with the total frequency. What are the total frequency? Just add up the frequency here. So 3 plus 5 is 8, 8 plus 8 is 16, 16 plus 7 is 23, 23 plus 6 is 29, 29 plus 1, 8 plus 2 is 31. So just divide by 31. Everything will be divided by 31. And then the percent, we just have to multiply by 100. And then for the cumulative frequency table, we just have to find the upper boundary. Here we have 8.5, 12.5, 16.5, 20.5, 24.5, 28.5 lah. Because why? Because we had up the 8 and 9 and then divide by 2, we have 8.5. And just add up by 0.5 here. Everything will be add up by 0.5. Now just find the cumulative frequency. So the first one should be the same, 3. But for the second one, we just have up with the previous cumulative frequency, which is 8. And then 8 add up with 8 will be 16. And then 7 add up with 16 will be 23. 6 add up by 23 is 29. And 2 add up by 29 is 31. So these are the results for the cumulative frequency table. So that's all for this lecture 1. All the basic information and knowledge that you have to know for the statistic data description. So thank you for this class. So continue with lecture 2 soon.